Dear students, I am Kavita BS, Assistant Professor, Department of Physics of Government First Grade College, Tiptur. In this class, I will explain the calculation of atomicity of diatomic gas molecules. This topic is in the course BSc Physics subject, paper 3rd, Thermal Physics, Radiation and Optics 1, and this topic is in the lesson Thermal Physics of Unit 1. Let us start the class. In general, atomicity of any gas molecules can be defined as the ratio of specific heat capacity at constant pressure to the specific heat capacity at constant volume, that is Cp by Cv. The ratio of Cp to Cv gives the atomicity value of particular gas molecules. In order to calculate the atomicity value of gas molecules, first we have to know the values of Cp and Cv. By using degrees of freedom and law of equipartition of energy, and also by using Mayer's equation, we can calculate the values of Cv and Cp, and then we can calculate the value of atomicity of any gas molecules. So here we can calculate the atomicity of diatomic gas molecules. First, let us consider the value of degrees of freedom for diatomic gas molecules. The total degrees of freedom for diatomic gas molecules is equal to 5. Means diatomic gas molecule has 3 translational degrees of freedom and 2 rotational degrees of freedom. Therefore, the total number of degrees of freedom for diatomic gas molecule is equal to 5. Then, according to law of equipartition of energy, the energy associated with each degree of freedom is equal to half kT. Then, energy associated with 5 degree of freedom, that is the total degrees of freedom for diatomic gas molecule is 5. Hence, the energy associated with 5 degree of freedom is equal to 5 times of half kT. Then, the total energy associated with 1 gram mole of a gas is equal to 5 by 2 kT times Avogadro's number, that is Na. Here, Na represents Avogadro's number. The product of Boltzmann constant and Avogadro's number gives R value, that is universal gas constant value. On substituting the value of K and Na as R, then we get energy associated with 1 gram mole of a gas is equal to 5 by 2 RT. And it is represented by the letter U, that is U is equal to 5 by 2 RT. On differentiating this equation with respect to T, we get du is equal to 5 by 2 R into dt. Then on rearranging the terms, we get du by dt is equal to 5 by 2 into R. Here, the term du by dt represents Cv value, that is specific heat capacity of gas molecules at constant volume. And substituting the value of Cv, that is equal to du by dt, then we get the value of Cv, that is equal to 5 by 2 R. And then from Mayer's equation, we have one Mayer's equation, that is Cp minus Cv, that is equal to R. Then on substituting the value of Cv in this equation, we get Cp value, that is Cp is equal to R plus 5 by 2 R. Here 5 by 2 R represents Cv value. Then finally we get Cp is equal to 7 by 2 into R. Then if you take the ratio of Cp to Cv, that gives atomicity of diatomic gas molecules. Hence, On simplification, we get that ratio is equal to 1.4. So 1.4 is the atomicity of diatomic gas molecules. So this is the calculation of atomicity of diatomic gas molecules. These are the textbooks for your reference. Thank you.